So first of all, good morning for you all. Thank you for attending this session. I hope you all can hear me well. Perfect. So the title of this presentation is empathetic architecture, the human factor that you might be missing when designing your systems. Perhaps not very technical, as you're going to see, like all the other sessions later, but perhaps a good start of the day. Yeah, so when I was writing this presentation, I had a question in my mind, discussing with a colleague. So basically, we're discussing like when we got some system designs that was not working very well, the development was slow, and then the question was like, do they even think about us when they decide to do these kind of things? Do they like check with the development teams, like, or they just a drawing box in there and then yeah, asking us to build? So yeah, and then we start to be a bit more into the theory about empathy, like perhaps is missing in that, and that's why I come up with that. That's this presentation, and that's the agenda for today. So basically, we're gonna be talking about a few topics. We're gonna talk about empathy, about the theory, socio-technical systems, the Conway's law, the hidden monoliths, and the team cognitive load. And of course, we're gonna have some takeaways on that. Not necessarily in this order, but that's the main subject for that. And yeah, about myself, I'm Rafael Maia. I'm Brazilian, live in Netherlands since 2018. Live in Zandam with my wife, my dogs, and a babe to come. I work for ABN AMRO as a solution design chapter lead. So basically, well, I do system architecture and do some leadership with the architects of the team. Well, I like to be outdoors, playing in a volleyball club, in a football as well, all in Amsterdam, and that's about me. So the first topic, what is empathy? So the definition is, I just copied the definition from the Wikipedia, the ability of understand, to share, and resonate with feelings and perspective of the others. And then I will go a bit like in the kinds of empathy that you can have. So the first one is the cognitive empathy. So cognitive empathy is when you can understand someone's perspective. So you're sitting in your own spot, and you can see the situation and understand what is going on in there, and then perhaps, so if the person is not feeling well, and then you can picture yourself in that situation. So that's about cognitive empathy. Then we're gonna go for emotional empathy. So that's a bit more deep. So that's when you have the ability of feel what the other person feels. So there are a lot of people that are like that. So if you see someone sad, and then automatically you're sad as well, or the same with the happiness. And the third kind is the compassionate empathy. I think in the IT world we see that quite often. Because yeah, it's quite common. You see someone struggling in an issue, and then, well, perhaps someone with more experience can picture like how it was to be there solving that issue with the pressure, and the client perhaps very mad, and then people asking the developer to fix, and so, and then you like you're touched to go there and help. So that's about the emotional, the compassionate empathy. And yeah, so then we're gonna talk about the importance of the empathy, right? So we all work in teams, and or perhaps a different setup, but you always have interactions of people. When you use any of those elements, first of all, you build trust. So if you can understand what people is going through, so perhaps they will trust you better. So it fosters open communication. When someone can understand what people are going through, they will communicate better, and the team will flow a bit better. And cultivate positive relationships. So if you can emphasize with someone, and you work together, so your relationship will always be good. But what does empathy has to do with design a system, right? Because yeah, it feels like a very away from what we do. And in my opinion, it's everything. Unless you're working alone. So if you're working alone, perhaps you're going to need to have empathy with yourself when you're writing your code or designing your systems or writing the documentation. Because if you don't think that you write a piece of code and then on the next day you're feeling bad, but you didn't document, well, perhaps it was a very interesting solution that not even you is going to understand like 2 days later. So that's why I think empathy can collaborate on system designing. And well, on that, we're going to talk about empathy as a pillar, and then I will use 2 main things. So the first one is the human-centric design. So when you're using empathy in an organization, when you work in your work environment, you're going to improve the socio-technical systems. So you're going to make sure that not only the technical things are getting done correctly, but also the social communication with the team. And of course, collaboration and communication. Because when you're empathic and the communication is better, the collaboration is better with the team. So that can improve your designs. And well, as I mentioned, it can improve as well the socio-technical systems, and that's a very interesting theory. I'm not sure, are you familiar with this theory? No? Great. At least you learned something new. So that's the definition of socio-technical system. Also copied from the Wikipedia. Socio-technical system encompasses both the socio-technical and the social and technical aspects of the organization, recognize that the performance and the well-being of one component affect the other. So yeah, it's a bit abstract on that, but first let's drill down on that. What is the technical part, right? The technical part, I think we are all familiar with it. Infrastructure, hardware, software, and technology-related process. And the social. People, culture, relationship, and organization structure. Which one is more important? Technical? Social? Both? So, well, to exemplify this theory, there is a book. It's called The Unicorn Project. Have you read that? Great, one. So it's a great book. I'm not selling it, so but I didn't write it. But it's very interesting. So it's a novel about developers, and it tells the journey of a developer called Maxime. So basically, you know, she was there working in her team, very happy in a company called Parts Unlimited, and she was on vacation. Something went bad in the system, and then they needed to blame someone, so they blame her. Probably you already seen that happen in your company or heard a story from someone that something like that happened. And then she ended up in this project called the Unicorn Project. So it's a project that was not working very well with a lot of things. And then the book explores, like day by day, like the journey of Maxime on it. And well, the key concepts of the book, they have 5 ideas right there. So I will not go through because otherwise it will be all about the book. But those are the 5 ideas of the book. It talks a lot about the age of software and data and overcoming organization and technical debt. So basically the project was not running, and then it was a project that the entire company was expecting to replace. So basically the company was selling their parts of cars and being happy, and then other companies start to do that faster with software, and they were out of date because they had too many systems, a lot of missing integrations there. So they could not work very well. And then what I'm going to explain here, this image, by the way, is not from the book. I just use these AI tools because easy to copyright. You can see like a lot of elements of the socio-technical systems in the journey of Maxine in the Parts Unlimited. So the first one, when she got exiled to the place, to this project, she started to realize that it's not about the technical only. Like, there are a lot of bureaucracy and a lot of ways that the team set up to communicate with each other that, I don't know, things like, yeah, for you to get this certificate, you need to talk to person A and B and C and D, and then you need to get approval from A, B, C, D again, because, yeah, that's how they do it. And of course, the communication as well, right? Like, especially when you work in big companies, that's quite common that the different parts of the company talk in a different way. Sometimes they use different tools. They use email, they use Slack or Teams or I don't know, whatever. And you need to find out how to talk to them. Or even, you know, I've seen a team that in my current work that you are not allowed to talk to them. You need to enter a session that they are all there waiting for questions. It's quite interesting. And in the book, you see that a lot. So she explains a lot what the struggles of the day. And then you have the adaptative challenge. That's when the organization is very settled, you have a lot of politics. And people are not willing to change in most cases. Teams are not willing to change because they're doing their own thing. They don't have the complete view from outside. So, yeah, they are not willing to take the challenge. And, well, the main point of this book, in my opinion, is like the empowerment and autonomy. So she struggles a lot to get things done because of the amount of people that she needs to get in touch and get things approved, and aside from the technical challenge, that seems easy compared to all of that. But they are always seeking for empowerment. So in the book, there's a group that they are trying to automate builds, to create CI pipelines and stuff like that, and to empower the teams. And interdependency. So we're going to talk that on the next theory, but you have like the microservices that are not actually truly microservice. They are like well, a big service that is split in a way that you continue depending of all the services. So and it makes it very difficult to make change. So yeah, for me, like reading this book, I could see like this theory in practice on these 4 items. And well, to have success on this theory in the organization, they stipulate that you should the success is the product of the interactions of the subsystems. So what is subsystems? What is interaction of subsystems? Well, picture in an organization you have like the squads, the scrum teams, right? When you see the product succeed when you have multiple scrum teams work on it, is usually how they interact. So if they have dependency and they interact very poorly, the system will be very poorly built. So the interaction of it will define the success. So if your subsystem is working well, aligning the technical and the social, your design will be very good. Yeah, so the first takeaway of this presentation, it's aligning the socio-technical systems. Sometimes we focus too much on the technical or sometimes in the social. It depends on your role, right? So you need to align that. You need to make sure that your system is, your organization is very structured in a way that you put in the same importance on the social and the technical part. And yeah, so related to that, there's a very interesting law. Have you heard about the Conway's law? This is quite popular, right? So the Conway's law predicates that the design of any system will mirror the communication structure of the organization that designed it. What do you think about this sentence? Is that true? Do you believe that actually happens? How how your organization talks, communicates, will mirror the system design? Yeah. I think it's very abstract. It's difficult to tell. But yeah, well. So first one, well, that's like the implications of the law, right? So if you have fragmented communication, what do you build? Fragmented systems. So, but on the other hand, if you have effective cross-functional communication, you produce more integrated systems. I do think that is true in most cases. Like it's quite common nowadays. You have like a back-end teams and front-end teams, and then you see when they succeed is when they have like some sort of full-stack person in the middle making that happen, or I don't know, or they have very good communication with each other. They focus on the APIs first and things like that. But yeah, it can. I think these two sentences they can reflect a lot on what the teams can produce. And yeah, so it's a very important part, right? Because if you're communicating poorly, and if you believe in the law, so it means that everything that you design will be poorly designed. So you need to identify those things before, and to intentionally fix that. Yeah. So and that's one outcome of it. I think that's like is a quite common thing to see in most companies nowadays. Everybody works with microservice, I'm pretty sure. Is it true microservice? Do you really believe what your microservices are microservices? I see a few. Good. There are some companies communicating well, I think. But yeah, so that's the outcome. So you split things. You create like a front-end teams, back-end teams, and database teams, and then you split all these microservices. They need to communicate with each other. The communication is not good. What they end up building? Like hidden monoliths in very different layer. Or someone used a term that I found it very funny, distributed monolith. It's so yeah, and then you have like that picture. And so, yeah, that does not help either. So, yeah, and then we're going to talk about decoupling systems, right? Like, so, because if you have monolith, you have a lot of, you need to decouple that. And when you're working with the Conway's law, so if you're looking at well, my organization communicates well, so then I have a good system. So you need to be thinking like how I can decouple that, how I can like make a way that my communication will affect the microservices in a way that they are well designed. They are like truly microservices. They can deploy independently, things like that. And yeah, so and that's like the second takeaway of this presentation. So respect the Conway's law. Try to be like intentionally looking at your communication structure, analyzing whether this is like how you should be doing that, and to intentionally apply that to your architecture. So you can use these strengths. There are some things that, if you communicate poorly, you have things that you can apply there and then make it work. So in a way that your system will be affected in a positive way. And yeah, so from that, I'm gonna go back to, I mentioned a few times you have like a back-end teams and front-end teams, and then I'll talk about the team cognitive load. Have you ever heard of team cognitive load? Great, a few, 30%. Yeah, so basically cognitive load is like the mental effort that you have to understand a task or to understand something. And I will drill down on that with 3 kinds of cognitive load. So basically, the first kind, instinct load, is like, it refers to the load of the cognitive load of when you pick up a task, for instance, like you need to learn a new Java language, like a new language, not Java. Java, you all know, I think, if you're in JFL. You need to learn JavaScript. So you need to look at the JavaScript first, and it's going to be a lot of information, right? How things are done there, and then that's the instinct load. And so that's the first kind. The second one is strenuous load. This is about how things are presented, right? So one example of it is when you're in a refinement. Well, that's quite common. You're working in a refinement, someone is presenting a task, and if the person is a very, very bad presenter, right? So usually, yeah, what I see a lot, especially from senior engineers or from product owners or from architects, they most of the times explain things, already telling you how to do, with their own view, and that's very challenging for a lot of people, because imagine that you're hearing that, but you're thinking something else. So I'm thinking, like, I need to build a duck, and they're explaining how to build a rabbit, and it's not going to work. Eventually, you're going to build something in between that is very bad, and that's what this transload is about. So if a task is presented in a poor way, and yeah, you're going to have you're going to need more time to understand that, to process the whole information that you got. And yeah, and then you have the Herman load, that is like when you truly get it. So that's like it's the moment that when you download a new technology, you're playing around, you make it work, you're happy, but in the end, like in the back of your mind, you know that you don't understand how it works. I've been there a lot of times, almost daily, especially building proof of concepts with things. You make it work. It's fulfilling what you wanted to do, but you don't truly get it. And that's where when it clicks in your mind, like, yeah, now I know it. So then for that one, that's forever in your head. And well, then I will tell you a little tale. So if you start to work in IT for quite a while, so you probably identify yourself on that. So once upon a time, there was a boy learning how to code, learn how to program, right? So he was happy there, working a lot, study, and wow, he became like the ultimate backend developer, right? He learned a lot of things. He learned Java, C++, servlets, Linux server. Like these words, they are very weird. I could have used better, but you can imagine any buzzword because you all work with a lot of different things. So yeah, you learn all of that. Yeah. And then the industry, the IT industry is quite cruel with us, I would say. So I think I started to code like early 2000s, middle 2000s. So back then, it was easier. So for me, at least. I could do my JSF, JSP, very happy, could build my backend, front end. This whole JavaScript thing was not there yet. Well, it was there, but not very popular as is nowadays. And then you need to be a full stack developer, a DevOps. You need to work with security, a wizard, a Jedi you need to be nowadays. So the things keep just increasing. It's just hard. And that's the happy path. Oh, the dark side, sorry. The happy path is the hyper-specialization, which, yeah, some people take this happy path. Not everybody. Hyper-specialization is if you decide to be a backend developer, you're only going to focus on that. You still have people that work on that. And there is the dark side of it as well, right? Like a hyper-specialization can be tricky because the technology changes very fast. So you're specialized in something, and then nobody's using that. So you have like COBOL developers nowadays. So they're still working in some places, but perhaps it's not that easy to become a COBOL developer anymore. So it's yeah, you always need to balance that. So most of us take this path. So you become either a DevOps or a full stack or both, and work with some security on the side, because why not? You have to. So it's too hard to catch up. I'm not sure about you, but I struggle a lot with following all the trends. It's like too many buzzwords, and you cannot even understand the buzzwords. So a few, but because you ask AI to build that, and then they just add a lot of strange stuff like Java. Love it. And well, the other day I was browsing on Twitter, and that was very funny. Like that was a conference about Next.js, a JavaScript framework, and someone did that, right? They present like a button that call a function server, that do insert on the bookmarks. And when I saw that, I was like, oh, that's a nice joke. It's been a while, I don't see these kind of things. Perhaps like with GSP back in the days, you could do such a thing. Well, in a different way. But that's our industry. It's changed in a way. Like 5 years ago, that was bad practice, right? Like your front end should never access a database. Apparently nowadays it's not anymore. I'm not sure. Didn't investigate that yet. So it was just funny. Yeah, so, and what does it lead when you have to learn all those things, right? So it's hard to communicate because, well, if you're overwhelmed with a lot of information, and sometimes you need to explain things to your team, and it's just hard because you don't really understand what you're explaining, what you're doing. So, yeah, you struggle a lot. And the imposter syndrome. So you think you're not very good at your job because you cannot understand everything, right? So usually, if you're focused on the hyper-specialization, someone asks you a question, like you're hyper-specialized in Java, they ask you, what is up on Java 21? You know everything by core. Not in this case, because you have too much. You need to learn JavaScript, you need to learn PHP, I don't know, a lot of things. Slow delivers, of course. If your head is like occupied processing a lot of information of different kinds, you're going to deliver things slowly. Bad code, bad architecture, that's quite common. I think a classic, on especially on the bad architecture, is you see a lot of someone decide to use something such clean code or hexagonal architecture, and then they don't really understand before they start to implement. The code gets very messy. And what can you do? You're just learning. So it's very difficult. You're not happy. And the automation ends up on the burnout. That's like a path that you all probably seen someone struggling or struggled yourself. So very bad. And about the teams, right? Because we're talking about team cognitive load. I was talking more in the individual level. So when you have team members with those issues that we addressed on the previous slide. So the first one is that you see in the team, absence of trust. Sorry, not true. They don't trust each other. So yeah, it's quite common when the team does not really understand what they're doing. They will not trust the team members around them, and that's very bad for the team. Like, because trust is absolutely important. Fear of conflict. So another like classic symptom when you have like when you're not very well in the team, you're gonna fear to conflict your team members. Lack of commitment. Avoidance of accountability, and inattention to results. So those are like basic symptoms that you're going to see, and probably already seen that in your current team or the team that you worked before. Probably not all of them, but a few of them. And those are like outcome of the team cognitive load. Perhaps we should be revisiting how much you ask from the team. Like, are the tasks very complex? Are the technology easy? Do we have enough trainings? Things like that. And yeah, so then we go for the reducing team cognitive load. So the first one is, I find this one very important, especially when we go to the full stack DevOps, world, clean role definition and boundaries. So the team will work better when they have a clear definition, what they are supposed to work, what they have to. And of course, not limiting people to, I don't know, if you're working with as a DevOps engineer, so you're not going to create networks. Perhaps you say, well, you have this person that is doing that, this person is doing that, but everybody should know a bit. But you can balance that. You can use like some techniques for it. Simplify and prioritize, that's like it's like a classic buzzwords of agile world, right? Like you need to make things simpler. You cannot like have a big story that you're going to spend like a month and then perhaps you misunderstood and then you're going to build it all wrong and then you need to redo it. And of course, we have roles in the Scrum, for instance, to do that. Like a PO should be prioritizing things. Most of the times it doesn't happen, but the team should have a sense of we should prioritize what is actually important, what we need to build. So, and for that, you need to have a good understanding of the product. And that can free up some team cognitive load, because if you build things on the right time, the tools will be easier. The teams understand it faster. So that could help a lot. Communication, effective communication and documentation, of course. That's well, I think that's just being in a team 101. You communicate well with your team members. You document things well, so everybody knows. And document can be of any kind. Even a good, very well-written code is a good documentation. And that's like very important as well. Limit multitask and work in progress. That's one thing that I see a lot work in squads. You're working a task to, I don't know, build an airplane. And then, well, there's only one person working on the airplane because it's very complex. And then what does the team do? Let's build a helicopter next to it. Why not, right? I mean, I have time. I'm here doing nothing. So let's build an airplane and a helicopter. So then, when the team start to present in a review, for instance, they didn't finish the airplane on the helicopter, and it's very complex. So I think when I talk to business people, especially, that they're listening to development teams, they say, "Oh, I don't understand what you're doing, but it looks very complex," because it's exactly what is happening. So you have like a lot of big tasks you put all together, and then it looks like a lot, but you didn't finish anything. So if you limit that, like put some focus on it, again, going back to prioritize, let's finish this plane, and then we pick up the helicopter. And that could, limit a lot, could benefit on the reducing the cognitive load. And and feedback. Feedback, extremely important as well, because the team will react better if you are telling them that they're doing a great job, or perhaps not that great job, but extremely important. And here's the third takeaway of this presentation, that please mind the team cognitive load, even if it's not your role to define what the team is going to do or not. But always keep in mind, because that can affect people. And if it can affect your team members, it will affect you as well. So in the end of the day, you need to go back to the empathy and try to feel that that person is struggling with this whole full stack thing. You cannot keep up with the latest Java and the latest JavaScript with the new SQL queries on the button of the front end. It's very difficult. So mind the team cognitive load and try to do something about it. So, well, I would like to wrap up this presentation. So we've seen so far 4 main things: empathy, the socio-technical systems, Conway's law, team cognitive load, and those are the takeaways, right? Align technical and socio-technical systems, respect Conway's law, and mind the team cognitive load. But I do have one more point of this presentation. Just one more. Use empathy and be nice and listen. So, and those are the picture of my dogs. They're like just playing along. I find them cute, so that's why I put them there. But you're working with humans, and humans have feelings. And so be nice in the working place. Try to understand what people is going through with, if they're going through some problems in their lives, and if the technology is too difficult for them, and things like, well, you're in an amazing conference today, you learn a lot of new libraries, a lot of new languages or anything, and then you get there tomorrow, say, hey, let's refactor that service, and then let's add this new technology there. That is very nice for a lot of people, but also mind that for some people that will be very, very difficult, because all of a sudden they need to do some things. Of course, I'm not saying that you should never innovate, but take people into account when you're doing such a things. So you cannot just start a new project in Kotlin and say, hey, everything will be fine. You need to train people, you need to convince them, to listen to them, say, hey, what do you think about that? We could improve that and that and that. So yeah, I think that's my final message for this session. Be nice to people, listen what they're feeling, and use empathy. And yeah, thanks for your attention. Hate this session on the JFall app. And if you want to stay in touch, here's my stuff. And thank you.